So hi everyone. So I just took your picture, so I hope it's okay. If not, let me know and I will delete it. So today I'm going to speak about. Okay. Okay. I will speak closer to the mic. Um, Today I'm going to speak about AI agents being leveraged in the SOC. I actually changed the subtitle of this presentation because, like at first it said AI agents will actually, it implicated that it will going to replace SOC analysts in the future, but this is not what I'm thinking, and this is not what you will get out of this presentation. So, like when we are seeing the future SOC, like I see it as a collaboration between humans and AI agents, and we'll dive into it right away. So at first, I want to introduce myself. I'm Oudy. I'm currently working for Microsoft as a research program manager for our XDR SIEM solutions, Defender and Sentinel. Mainly working on the quality aspect of our product, meaning that I'm spending a lot of my time making the product better. Before that, for many years, I worked for big four companies on the offensive side, leading red teams, assessments, research programs, and so on. And like the beginning of my career was on the critical infrastructure domain. So like I know, let's call it the challenges from both sides, from the attacker perspectives and also from the SOC perspective. And let's dive into it. I won't read through the agenda. I want just to say thank you also for Sarah Young, who was mentoring me for this talk, and the B-Sides team for accepting this talk. This is my first time speaking in this kind of conference, international conference, so thank you very much. By setting the scene, I will start with the SOC challenges that we are currently, or not currently, but we have when operating a SOC. So the first thing would be that SOC analysts actually spend a lot of their time chasing nothing. Like half of it would be just to triage signals and trying to investigate incidents that are not really there. Like you can see two reports, one by Sense and the second one by Microsoft, that describe these challenges. There is a lot of volume. We see like an increase of 13 trillion from 2023 to 2024, and like most of my work is to get it actually decreased during 2025 and like later. So this is a main challenge. It causes fatigue. And it also actually makes the analysts feel that much of their work is actually for nothing because they're not having an impact on the business afterwards. Of course, the threat landscape is also evolving. There's more sophistication, mainly also attackers use AI in order to attack. Like I did it, my team did it, and also, of course, real attackers that actually targeting in a lot of companies are also doing that. And also something that to know that most of the organizations actually have an attack path, live attack path to a critical asset in the network. So that's also something to note, meaning that there is something out there to chase. And I don't remember any penetration test or red team that we didn't achieve our goal. And like I spent 3 years attacking Fortune 500 companies, and I don't remember any example that we didn't succeed in a way to get what we wanted out of the goals that we set up front. So this is a very big challenge that most organizations are facing. So what would be like the ideal experience? Like if I was sitting in a SOC and I was an analyst, I want to have only true positive incidents, meaning that each operation that I'm doing is actually makes sense and providing some impact on the company. I would also want something to prioritize it, even for me, that my next action would be actually the optimal one. I wouldn't want to chase, even that if it's true positive, I want to chase something that is actually has the most impact on the company. I would want to have some kind of automation for triaging, also for response. We will spend a bit later talking about that. I don't think it should be automatic, but it should be in a way. And the system should also learn from past experience and implement that on future work that humans and also agents would do. So this is like the ideal experience as I see it. And there are actually like many more things, but this is like the main things. So this describes how detection evolved from like pre 2000s until now, and I will also describe each phase and where I think we are right now. So we started by alerts, which are distinct and discrete logic that actually implicates suggest on a specific event that happened. It can be like a port scan from IP X on machine Y, but it doesn't tell us the story. It tells us a specific event that happened. An alert says that it has some sort of a security, let's call it security. You need to act on it in order to block the specific threat. And this causes a lot of noise. We are still, like most organizations are at this level right now, ingesting a lot of alerts from dozens of products to a SIEM. And analysts are investigating like one by one and spent a lot of time, as we said, half of the time chasing actually nothing. And then it evolved to incidents or cases, which are few alerts grouped into a specific, let's call it a container, that suggests on a story, but it's still not like, it's a big leap, but it's not where we want to be. Because here we understand like what happened. The story most of the time isn't complete. We see bits of it, but we don't know the intent and not the impact. Where we are right now is like Gen 2.5, as I call it, which means that we have machine learning and graph algorithm that enhancing these alerts. If incident-centric signals were like correlation of entities, meaning that the same IP is on specific alerts, and then we understand like the concept of the incident. So for machine learning, we also can leverage patterns that we see and behaviors and so on. But it's still not something that suggests on, like it doesn't have a reasoning behind that. It's just like patterns that we can have the machine learn and spot incidents based on that. So the next generation would be to understand the reasoning behind all of this. As a human analyst would do. It can be tier 1 or tier 2 and so on. But the job of the analyst would be to understand the reasoning behind what happened, find more relevant signals, and have a complete story end to end that describes what happened, why it happened, and what's the impact on that. And there is like a model that describes all of that from an information management, which called the DIKW model. So at the base, we have data, which shows all of the discrete events that happened. After that, on top of that, we have information, which is where we are right now. So it contains like incidents, alerts that suggest on what happened. They provide some insights on that, but usually there is no context. So there is some knowledge above that today with many products, but we are not at the wisdom level that suggests on why it happened and so what we are going to do. And this is like the reasoning that I'm speaking about. Okay, so why do reasoning and intent matter even? So as I said, prioritization. As analysts, we want to have, again, the optimal next action to take in order to do our job better. So here we have like the agents that can help us, and I will describe them in a minute. We want to know what happened, but also why and how important it is, what's the priority of taking care of that, and what's the potential impact. We also want to have the reasoning behind that. So the machine won't just say, this is important, go do it. No, we want to understand why. Because if we want to make decisions based on that, we need to understand why. So what are we going to do? We can harness a bunch of agents. And this is not a complete list, of course. And I will describe later maybe some more functions that can also be leveraged. And we will go like by each one, and I will describe each one and its intent, how it can assist us, and so on. And it's actually 24/7, right? It doesn't depend on if an analyst didn't sleep well at night or had a fight or is not concentrating. It's always there, helping us, assisting us, and making sure the analysts are actually focusing on the right things. So this is something that I need to read because there are some demos in the upcoming slides. So all the examples that you will see, it's actually it's not in production. It's real client data, but it was copied, scrubbed before it enters our demo environment. So it's like real data in there, but it's scrubbed. It's a test, and then we can have like this kind of environment that we can test our agents and other things in order to see if it makes sense, what are the results, and so on. So the first agent that I'm going to describe is the orchestrator, which is kind of, let's call it the shift manager, or the agent that will trigger the other agents. It will do the process it can be like automated playbooks. Think of it like you can import all of your SOPs, the standard and the procedures that you have in the SOC, and have the orchestrator act based on that. It can parallelize the tasks, meaning I will show you this in a minute. And also it coordinates between everyone, meaning that it can take one output and then forward it as an input to another agent, so it will be like as a process and not a discrete specific task that some agent is doing, and it's not connected between for the overall process. And most importantly, it can foster the guardrails, meaning that if you don't want something like some automated action that will happen, we can set it here for the orchestrator, so nothing will happen until we set this as something that we approve. The investigator is where things start to become interesting. So think of it as a tier 1 or even like a tierless agent that its goal is to ingest all of the information, parse it, and then look up the context. Meaning that it will understand what is that IP. Is this machine belong to someone's, I don't know, our CEO, or is this server, what is this server is doing? When we have alerts that saying port scan on this IP, we don't understand what is this IP, right? So it will look for the context. It can also leverage threat intelligence. It can be general threat intelligence, meaning that we have specific report for a given threat actor, and it can be also our own threat intelligence that we know that we are going to be targeted by a specific threat actor with specific TTPs, and so on. And its goal is to actually gather all of this data, connect the dots, and assemble a story end to end. This is the goal of this investigator agent. And as if someone here is working as an analyst, this is actually what the analysts are in charge of, the tier 1 analysts, to have all of the data ingested, build the story, and later on act on it. And of course, it cuts the noise because it takes only what is belong here. So here there is like a real benefit because it's not entity-based. It's not a specific IP that we saw, and then we try to look for other alerts that has the same IPs or the same machine. It actually reads the entire text of the alert and try to find patterns in other alerts to have a complete story. So in this example, you will see a business symbol compromise attack that it assembled from 4 alerts. I know you can't read all of this, but I will highlight the important things. If I remember correctly, the first alert that actually someone noticed was that we have a high volume of spoof emails sent from a given account. But we had 4 alerts actually in the system. One said anomalous IP address, and we will get back to it in a minute. And also an inbox rule that got changed by an unauthorized person. So those alerts were there, but they weren't connected into an incident. So the agent actually connected them. And he also found another alert that it wasn't an alert, it was an event, a search event. So the same user that got compromised searched for specific words in SharePoint and OneDrive. One was tax, and the other one was mobile bank or something like that. We will see it in a minute. So it added another context. It also it was bank, mobile, and tax. And also the anomalous IP address, which if someone here works at the SOC, this is actually an informational alert, if any. So when he did like the reasoning behind that, he found that this is a specific IP is actually a Tor proxy IP, which suggests on a specific attack group in this case. It also found the root cause, which is actually also a task that we are doing at the SOC. Provided the timeline, the executive summary, and the root cause. So this was the output of this specific agent. So now we have the story, but is it the most important one? Is it even true? We don't know it yet. So the next agent is the prioritizer, which would, it's like a tier 2 analyst. He will triage the event. Classify it as true or false positive, even provide us with a confidence level, and we will see it in a minute. And then we provide the reasoning behind that. So this is it's actually a skimmed output of the agent, but we can see it like it triaged it as true positive. The confidence level is 90%. And based on that, actually, we can also have the orchestrator have a logic saying, if you've seen a true positive score more than X, then do that. So it also can be leveraged later. It provides us also the reasoning behind that, which is the most important part at this output, meaning that it's not just a number, but behind that there is the story. And of course, it provides us all of the IOCs, which we need later in order to respond. And also provides the recommended actions. As we will see in a minute, we will leverage that in order to conduct manual or automated efforts afterwards. So the responder is next in line. So now we have the story. We know it's true. We have the confidence in it, and now we need to act on it. So the responder is like our firefighter, let's call it like that. It can suggest on what to do, but it can also do it if you connect it to the right systems, of course. So it can like block a specific account, it can add some rules and so on, and do it at machine speed. So you don't need the analyst always there. So if a specific actions were permitted by the orchestrator and it happened, I don't know, during the night and there is only one analyst in the shift, the agent can do it instead. And of course, it's consistent, it's always there. So until now, we had some sort of a process, right? We investigated something, then we trashed it. Afterward, we responded. So this was like a process, but we can also parallel some stuff. And the hunter would be one of them. So right now we have an IOC, but maybe we have more phishing emails that someone got and other things that got compromised. So this is the way like to hunt further and find similar threats within our environment. And this is like second line of defense. So here you can see also the output. Because we don't have time, I won't mention that. And just I will say that this is specifically like we have less false negatives, meaning that there are maybe something that we missed. This is the way to get it less. The last one that I will describe is the blacksmith. This, like once we have a specific incident, we can then write a new detection rule based on that. Because let's say before we didn't have a rule to detect specific keywords in the search, so now we can write that, for example. So it will take what we learned and apply it for next actions. And this is an output that is specific for this specific incident. Here we see the JSON. We have also KQL for that. And it wrote a rule. We also compare it to like real humans that are writing those kind of rules in the SOC. And we saw it's actually comparable. So this is the process that I described. And so we can also parallel some stuff. So the impact would be less noise, faster containment, meaning that the mean time to response, the time that analysts take the time in order to respond to the threats will be much less. The efficiency go up. Also the burnout go down. And the SOC would be more efficient and more effective leveraging that. So the adoption path. I don't say that you need to go tomorrow and implement all of that, but you can start small, define a process, find your pain points, and have a specific agents to address one of them. Pilot it, integrate it into your existing stack. I think the most important thing here is that it's product agnostic. It doesn't care, it's a text. So it doesn't matter if it's, I don't know, a SIEM by company X or an XDR by company Y. As long as you ingest everything, it can read through. Then you can expand, always measure, iterate, and of course train your SOC in order to leverage all of that and collaborate with agents and know like where are the boundaries, as we have like the shared model in the cloud. So it's kind of the same here. So wrap up and key takeaways and looking ahead. So as I mentioned at the beginning, I don't think that agents will replace the analysts in the SOC, but they will make their life much better. They will let them concentrate on the more important stuff and not doing all of the time consuming and actually chasing a lot of false positives. So this is how I see it. And I don't know if we have time for questions, but if you have some, you can also reach out. I must say that this is a key here, and currently we're leveraging large language models. And the more you invest time on that, training actually SLMs and not LLMs, it will decrease the cost by like 90-something%. And this is what we are currently chasing in order to implement it at scale. Like we have the technology right now, but so it will be beneficial for our companies. We must shrink it and have it like targeted for security and not like, I don't know, fishing and hiking in the desert. Yeah.
Thanks for Thanks for the talk, very interesting. Throughout this entire processing, are you using also data that is not trusted? I mean, do you have like snapshots of data that from the alleged attacks? And if you do, how do you deal with concern that some prompt injection somewhere will actually take over, do intent manipulation for the entire process?
So what you also, it's actually backend. It's not something that someone is prompting in order to do that. We do want to have we call it like a vibe hunting in the future, that the SOC analyst will like input their questions or what he wants to do, but it's not there yet. So currently we're not dealing with that, but this is a great question and something that is very concerning, I guess.
Thank you.
Thank you.
Yeah, likewise. Great talk. So question is on the kind of the orchestrator, or I can't remember what you called it, the kind of planner agent at the very beginning.
Mm-hmm.
So you mentioned it's going to be fed with kind of your SOPs and things like that. How are you dealing with kind of just the unstructured nature of those in terms of some are playbooks, some are just kind of handwritten notes, and then ensuring that the agent always follows at least the top kind of SOPs that you've defined, so say for business email compromise?
Again, a great question, because that's actually also something that we invest a lot of time on. So when you are ingesting a lot of data in a whole source of information, like the model is supposed to take care of that. But then you want to, as you described, know that it will follow it. So there are some, let's call it strict boundaries or guardrails that we are embedding in the code in order to do that. So right now it's like, since it's not scaled for all of our customers, it's quite easy. This is a challenge, and we will need to figure that out.
Cool.
All right, thank you everyone. If someone else wants to reach out, please feel free. Thanks.